A warm welcome to all the participants to the afternoon session of the AICTE sponsored STTP. Welcome to Mr. Swapnil Srivastava sir to this session. Welcome sir.
Hi Deepa, thank you so much for inviting me to this session.
Let me introduce the speaker to the participants. Mr. Swapnil Srivastava is working as a data scientist at IBM. Sir has completed PGP AI/ML from Great Lakes Institute of Management in the year August 2019. Mr. Swapnil is skilled in business analytics, statistical and predictive modeling, agile methodology, etc. Sir has completed his MBA from Alliance University. Sir has won more than 10 awards. Let me name a few of them: the Resiliency Champion Award and the Hall of Fame Award from IBM. Welcome, sir, to this session, and I hope the participants will make key takeaways from your talk, sir. Over to you, sir.
Thank you so much, Deepa. Hi team. Thank you, Deepa, for inviting me to this session first of all. And just a quick background. So, as Deepa mentioned, that yes, I am in MBA. I did my MBA in Operations Management. I have around 6 years of experience in the field of data analytics and data science. Currently, I'm leading a team of data engineers, data analysts, and data scientists for a prominent healthcare account in United States. Uh, my day-to-day work is related to connecting with client, working on different data science projects, monitoring the project health status of various initiatives that are being taken from IBM front, and manage the entire end-to-end data science solution. So that is my brief introduction. Now, quickly, I would like to share my screen and take you through the topic which we have selected for today. So, Deepa, just let me know if the
Yes, sir. Yes,
screen
sir.
is
I
visible.
will. So, have you shared the screen?
Yes, I have shared the screen.
Okay. Is it the MS Teams? Okay, sir. Yes. The
It
PPT is
is
visible.
visible,
Yes,
right?
sir. Yes,
Yes,
sir. Visible.
it is visible. So quickly, I will. The agenda today is going to be, uh, you know, understanding of machine learning categories. And when I talk about categories, basically they are different types of algorithms that we hear about. For instance, someone will talk about, supervised learning. Someone will talk about unsupervised learning. Someone will talk about, artificial intelligence, machine learning, and things like that. But what is the basic difference between them? I would like to, give a brief about that. We will understand from a data perspective what are different modeling techniques and their use, especially into the healthcare environment. And I will be taking you through one use case of identification of Parkinson's disease. It's a uh, open case. Reason being, majority of work that we are doing in industry is we have to sign an NDA, non-disclosure agreement, so we cannot take you through those. But yes, this one is an academic case where people develop. The data is open source, and as a learning, the participants or the students or the research engineers, research developers use this case study to try, test new models, and develop new theories. Even multiple papers had been presented on this certain topic. So that is identification of Parkinson's disease in prospective patients through machine learning. Okay, so before moving to this, multiple times people come to me and say that, Swapnil, what is the difference between data engineering and data science? As I start my topic with that to give a brief background. What are the different roles in this domain, and how usually they are differentiated. So initially, when I was talking about that, I'm leading a team of data engineers and data scientists. The difference is, if you are working with a data science project, right? So in that, there will be basically 2 or 3 major teams involved. It can be more than that. There could be a project management team as well. So starting with the first one is your data engineers. Now, these data engineers are the people who develop entire background of data for any project, any machine learning, any artificial intelligence project. You need to have uh, databases, and from these databases, first of all, there should be an input source to these databases. These database can be your image database, your or your SQL based database, which is your rows and columns, just to make it easy to understand. Now, the data engineering team works on the management of data here and how the data is being going to this database and moving out of this database for the data scientists to utilize. Now, data scientists are basically the teams or data. I can either mark it as data scientist or data analyst also, who will work on your exploratory data analysis. They will do the initial analysis of the data which is coming into the queue from data science. So here the tools like data visualization tools like your Tableau, you would have heard of, Power BI, advanced tools like Kibana are being used to do the data visualization, or programming based data visualization either through using Plotly. Plotly is a package from R, and it is available on Python as well. And in Python we have multiple, for instance, Matplotlib, your Seaborn. So these are the different libraries, but these are the tools which are being used for data visualization. And for exploratory data analysis, the data analyst or the senior data analyst will do the data exploration, or a data scientist will do a data exploration to understand the data which is coming inside. So based on the problem statement, these people will try to understand that what can be built or what can be done or what not can be done. Now moving forward, there will be again a data scientist or a senior data scientist who will work on modeling. So here modeling means developing if it is a predictive modeling problem, if it is a prediction problem, or if it is a forecasting problem, any kind of problem, but that person will use the data to develop the model. And again, this data will go back to the data engineering team. So the data engineering team will come in practice. I'm showcasing it as DE. So this DE team will use this model to develop a production model. When I talk about production models, see, when we are talking about corporates are interested in return on investment. And I think everyone will agree to this, that if we are developing a project, if we are developing a product, or if we are developing a software, what is my return on investment? If I am using a team of data scientists and the entire from data procurement to final model development and releasing into the for selling it to some healthcare environment, like companies like say Apollo in Indian environment, or companies like AIMS, or hospitals like AIMS. So if I'm going to sell them to a product, what is my return on investment? If I'm investing, let's say $100,000 on developing our entire pipeline, will it be beneficial for me or not? Now, another way of this is also doing research. For example, Google does research. So they develop a product, or they develop a software to make sure, first of all, to make sure that the research is done and the research paper is published. And then they will think about, if the research is successful, then it can be moved to the production, it can be finalized as a product and released in the market or not. So majority of the corporates will have this sort of structure with various teams getting involved to complete a data science project. That's why I say that data engineering is aspect where they deal with the data management. Data scientists plus data analysts are the people who work on the exploratory data analysis, understanding of the data, and based on that, developing the model. Now, one more segment comes here is domain expertise. Now, these domain experts, for example, when I'm talking about healthcare, so I was working with one of the hospitals to develop a product for them, and we needed understanding of how the data, what is the data, what are the metrics that needs to be tracked from the data. For instance, let's say I'm taking a blood sample, and in blood sample, what are the different attributes that I need to understand to develop my model. Okay, so these domain experts come from, they are hardcore trained, the doctors or physicians or your clinical people who understand the pathological environment of healthcare. So, so that is the brief understanding that I wanted to share from the beginning. Let's Because I will be using these terminologies on and off during the presentation. So I hope it is clear. Now, let's move into the presentation. The topic today that we have selected is machine learning categories and algorithms which used based on identification of Parkinson's disease. Okay. I'm moving to the next. So, first of all, let us understand, why all excitement is happening. And the excitement is happening because a lot of innovation is happening in the entire environment of artificial intelligence. For instance, this is Sophia, and Sophia is a humanoid. She understands now, right now, she's at a level that she even understands emotions. Okay. Then we have something called as IBM product, which is Watson. And Watson won Jeopardy. Jeopardy is one of the games, and Watson was the quickest among the fastest human beings which are available in this game. So Watson won that contest. Now, a lot of companies are investing huge amount, huge amount in self-driving cars, especially Tesla. If you talk about all major companies right now are trying to build cars which are self-drive autonomous cars, and they don't need a driving support. Still, for self-driving cars, we are still around a decade far away. Yes, the testing is happening, but the environment is such chaotic that an AI model cannot predict each and every move of human beings. Then the artificial intelligence that we are using currently, a lot of personal assistants like Siri, Bixby, Cortana, Alexa. We all are aware of these different personal assistants, yeah, which are helping us in running our day-to-day life. For example, I own a Samsung phone, and Bixby is one of my personal assistants. And as soon as I said Bixby, my phone is giving me a pop-up that Swapnil, what do you want to do, or is there any query that you want to ask? Before joining all the meetings, my all entire meetings are being registered on Bixby, and it provides me a sort of that this is a certain meeting which you are going to attend in next 5 minutes, and things like that. So these personal assistants are a form of AI which is being used in day-to-day life. Let's talk about visual recognition, facial recognition. Facial recognition is banned in most of the countries, is what I want to share the message here, because in different countries, facial recognition is being used in positive and negative ways both. A lot of research is happening in this area to identify how to develop a optimum facial recognition model which is not giving output based on any race or any gender or things like which are related to human beings. So it should not give a darker color person always as a thief, or an Asian person as smart, and things like that. So a lot of studies happening in facial recognition area, but yes, it is something which we are seeing in our phones, that our phone is able to open itself as soon as it finds our either retina contacts or your face recognition. In terms of products which are personal, here we are using facial recognition, but a lot of research is happening in this area. Now, the last one that I'm talking about here is Amazon's and Netflix recommendation engine. Recommendation engine is something which is generating revenue for companies which are in either e-commerce players or web content players. Now it is also being applied into areas like open courses, that you have done this course, you should opt for the another course. For example, you're doing an AI course, you should also do an IoT course, things like that. So we all do. I believe everyone is on different platforms for doing their online shopping. It can be Myntra, it can be Jabong. Jabong is not there, but Amazon, Flipkart, and web content like Amazon Prime, Netflix. Now, a study said that 35% of Amazon's revenue are generated by its recommendation engine. Similarly, Netflix, 75% of users select movies based on Netflix recommendation engine. So the same thing is being applied in healthcare as well. Uh, if you go, doctors are using these technologies in different areas. Okay. So moving to the next one. Now, let's talk about something you are talking about other industries, but what is happening in the healthcare industry. Now, this is a recent development by Google. So Google's new AI algorithm was able to predict heart disease by looking at your eye. That means your retina scan, and it was actually identifying three major things. So the image that you see towards your left, first of all, this image is your eye image, and it is called as fundus, the fundus. Now, on the this is the rearest part of your eye when you take the scan, when you take an eye scan. The rearest part of our eye is full of different veins carrying blood vessels, right? So the image towards your left is the original scan image, whereas the image towards your right is your image scan after passing through, or what the AI model that has been developed is looking at it. Okay. Now, with the help of this, they were able to deduce correctly the age of the person, what is the blood pressure, most important, whether the person smoke or not, or has been a smoker or not. Now, based on these plus your blood sample reports, the AI model was able to predict if there is any risk of major cardiac arrest or major cardiac event to happen. Imagine, quickly, within fraction of minutes, if a model just these data points of a person passes through it, the eye scan, retina scan, and the blood sample report, and with that the model is able to predict that yes, this person is having symptoms related to cardiac event, or in future that person can have cardiac arrest, and the doctors take decision on this. Now, yes, there are chances of false negatives. There is a lot of research happening. Currently, this model is not in production. When I mean production, that is, it is not being shared with different organizations. But the research is happening. Google is trying to increase the efficiency level of these models, of this model, and more data is being pulled in. More research is happening to identify critical predictors so that the model accuracy can be increased. For this certain, to develop this certain algorithm, around 300,000 patients' records were taken with eye scans and general medical data. And you can imagine the volume of data that goes into developing this model. So that's why I'm saying that these models are heavy. They are being developed on a lot of data, and that's why we can say that yes, the accuracy levels could be correct, but at the same time they need more refinement, more consultation from humans to understand that yes, the output generated is correct, and a lot of it cannot fall under the legal actions, right? So that is something that is happening in healthcare. Healthcare, this is not the only example. X-ray scans to identify pneumonia or chronic pneumonia, your X-ray scans to identify lung cancer, your blood sample reports to identify malaria, your blood sample reports to identify anemia. Now, these are being developed with the help of uh, computer vision. So the technology that you see, which works on the images, is computer vision, and they are helping to the research is happening in the area of identification of diseases with the help of these different reports. Quickly, so let's introduce healthcare AI. Now, when we talk about healthcare, it is mostly improvement of health via prevention, diagnosis, and treatment of diseases, illness, injury, and other physical and mental impairments to the people. Now, a lot of happening when I'm talking about it is not only diagnostic purpose, but robot assisted surgery, virtual nursing assistant. They are also part of your AI products that are being developed. Two major products that I want to talk about here is one, Zebra is a company which has developed an imaging analytics engine, and they call it AI1, which uncovers, it uses your brain, lung, liver, cardiovascular, and bone disease CT scans to identify diseases. And a lot of preventive care programs are being taken based on the output that is being received through this artificial intelligence model. Similarly, Freenome, again, another company which developed multinomics platform which helps in detecting cancer. So it allows to process different forms of immune and tumor in the blood, and then based on that, it gives the output in terms of that person is or prone to cancer or not. Quickly, so any questions till now? Deepa, I can ask. People can go ahead and ask questions if in between required.
Yes, sir. One question was posted by a
Mm-hmm.
participant. Can I read it out?
Yes, please.
How to reduce the background noise in self-learning algorithm? One second.
Uh,
Let
sure.
me read a complete. How to reduce the background noise in self-learning algorithm in real-time analysis?
How to reduce the background noise in self-learning algorithms in real-time analysis. There are different ways to reduce the background noise. For instance, if you are talking about, let's say, uh, uh, if you are taking an example of natural language processing, right? So in that, you have to pre-process the data to make sure that the self-learning algorithm that is being used, for example, it is called as transfer learning. If it is being used, it comes to the same format. So a lot of data pre-processing required. In terms of computer vision algorithms, now there, the self-learning algorithms, we have to feed in, for instance, the Google example, the Google first computer vision model used to extract the information of age, blood pressure, and whether the person smokes or not. Okay. Now with this three information, it goes. So the background noise, apart from anything else that the algorithm capturing is removed. Only the information that has been taken is your age, blood pressure, and whether the person smokes or not. Now this information passes to your another algorithm which takes care of doing the prediction in terms of the person is having risk of suffering from cardiac arrest or not. So multi-level predictive models or your different uh, addition of identification of different attributes, extraction of different attributes from the data helps in reducing the background noise. Now, first of all, self-learning models, when we talk about, we have to do a lot of data pre-processing to make sure that the noise is being removed. Noise can be in terms of your bias, that the data when it is taken, it is captured through, if it is captured, let's say, through human sources, then there could be a bias. Okay. So that is something. Apart from that, we have to understand the environment from which the data is coming. For example, let's say one example in healthcare cannot be 100% end-to-end applicable in banking. So you have to understand that from which industry the data is coming. One more aspect to is it is let's say different regions. So the the body temperature of a person who is living in, let's say, desert or hot, warm or humid cloud region will not be same as a person who is living in a tropical region. So region also matters, and that's why a generalized AI is currently not, it is near to impossible. Yes, a lot of research is happening, but a general AI is not coming out of any of these. Whatever AI that you see currently are trained. When I mean that they are trained, that means there is a person who is sitting in the background using different codes to make sure that the AI works, and the models are being trained on a sample data. It is not the universal data that is being taken. We only take a snippet from the universal data, which is your sample, and on the sample data, your model is being developed. So, to remove background noise, there are certain steps you have to understand. You have to do your exploratory data analysis. You have to do a missing value removal. You have to do perform, let's say, outlier removal, things like that, and then only you can develop a. Then only you pass your data to the algorithm so that the algorithm learns uh, at best. Else your accuracy will differ. Let's see. Okay, there is a question that are there any open source based benchmarking tools to evaluate performance of an algorithm? The benchmarking of algorithms or the performance of algorithms differ again from industry to industry. So, for instance, in the banking industry, for a model which is to identify or that the person will give loan or not, will return loan or not, or the person will be loan defaulter or not, we have reached to a level where the model can give accuracy above 90-95%. But similar is not the case of medical research. Now, in medical research, we have reached up to a level, for instance, the last example that I have shown for Google, they have reached in that particular problem, they have reached a accuracy of 70%. That means 70% of the times the algorithm was able to predict if the person will suffer from major cardiac event or not. So there is no benchmarking in terms of industry at an industry level. At a particular product level, for example, if you're talking about chest X-ray, now in chest X-ray, if there is a competition happening, or if there's you have to develop a model, you can go ahead and look into Kaggle competition. Now in Kaggle, people on the similar data set, a lot of research. For example, last competition was related to X-ray pneumonia, and one more competition came which was to identify disease in your eye, which was from Arvind Nisrale. Arvind, the data was provided by Arvind Hospital. So these competitions are there, and based on that, the research paper are available. Now, when you study the research paper, when you are developing a model on similar environment, for instance, let us take the eye one that Arvind Nisrale shared the eye scans to identify different eye diseases. Now, if you are doing the same job, then you can go ahead and take benchmarks from the models or from the models which are published through Kaggle competition. Apart from that, I see research-based learning is one of the good source to make sure that your models are how your model is performing. Okay, so let me quickly move to the next segment. Meanwhile, if you have any questions, please keep on posting it. So just a brief. I took this introduction, but I'm just sharing this slider with you guys. Whenever we talk about any data science project, as I mentioned, right, it is different teams coming together and working on one given problem. Now, your problem could be basic problem just to identify, for instance, that the person will give a loan or not in banking industry, or it could be a forecasting problem that what will be my stock in the next coming hour, or it can be a major problem is to identify, uh, for example, the person is suffering from a cancer or not, right? So again, a problem statement is given. The problem statement is understood by the entire data science team, and then they go ahead, they either formulate a team or the team is already available to work, and those set of people work on the problem. So in that given scenario, majority of the your big funding companies, your top companies which have major market share in the IT industry or in the software industry, for instance, companies like IBM, companies like the T Systems, there's companies, new companies also, startups also coming in this area. Amazon is one of the prominent players. Google is one of the prominent players. They have a team. They have a complete team for computer science, or a team which takes care of your data engineering and your coding part. They have a team of uh, statisticians, mathematicians who work on formulating the formula, or they give the insight in terms of what mathematical model can be used in that given problem. Then you have different people from coming from background. For example, let's say it's a cancer problem. Then you will have an oncologist, assigned to the team. They will hire an oncologist from outside. That person can give the domain knowledge, so that all these understandings are brought in together, pooled in together, and then a data science model, the product is developed. Now, initial stages, you will see that there were software development teams, but in that we didn't have this much of granularity, because see, software development was that you have a set of processes. For instance, you have a if else statement, you have the attributes ready. For instance, let's say you want to develop a payment system. So in payment system, you know that there will be a button where a person will go ahead, click. The button will take them to the next page where he will, write the amount, and then after that it will move to the next page where there will be OTP identification, and then at last the gateway will connect to the bank and take the payment, and a receipt will be generated. So that is a process that can be seen through eyes. It is visually possible to see. But let me give you a scenario. So here, now this is a research idea to identify disease causing anomaly in microscopic images of blood samples, right? And the more simplified version is that identification of bacteria, yeast, fungi, or a virus in a given image. Now, let us say if you want to develop a model on this, and this is again a visual problem, how you will define the attributes. If I'm asking a software developer to define attributes of a image, which is of a stay file locus, I cannot even take the name, or yes, right? So how I will define the image? Because in place of this, there could be cotton balls, right? If I click an image of cotton ball and pass it on to the model, it might define it as the same thing. So coming to the problem, there are different lightnings, there are different angles in an image, there are different backgrounds, there are different level of occlusions. So these things cannot be hard coded. When I'm writing an algorithm, I don't have a if else statement that if it looks like this, then it can be this. No. And that's where your computer vision algorithms, there are different algorithms. For instance, ResNet 50, current one which is most prominent, which is taking on the market net, is efficient V7, right? So these different algorithms came in picture. The algorithms are developed by, again, statisticians, mathematicians, engineers, and a team of engineers who worked on these algorithms for years to focus on how to extract images, meaningful features from this given image, and then pass it on to a algorithm, and then on top of that develop a model which helps in understanding of which helps in solving the problem. And the problem here is to identify which virus is available in this given image or this given image or this given image, right? So that's why it is quite challenging to uh, fulfill a project which is correlated for data science, and that's where you need different teams to come together and solve the problem for you, right? So for instance, here, statistics for a data science model, what things that goes in statistics, visualization, data mining, database and data pre-processing, the neurocompetency, your machine learning, your pattern recognition, all these things go through a data science model, and then you see the output. Just a brief history. So data science is not something new. A lot of research has happened. A lot of people with prominence worked in this field, and then currently what we are seeing is an era of moving towards your artificial intelligence and and quantum computing. So starting with uh, R.A. Fisher, he came up with the design of experiments. It's still prominent. It's still being used. I use it whenever I'm working for a new product development project. So design of experiments came in 1935. Then Deming, he's the father of quality, or named called as father of quality. Deming came up with quality control in 1939. All these different quality 7QC tools are still, for instance, I'll give you an example. We had a challenge to make sure or to monitor the performance of a given model. So the model was accuracy was around, or F1 score is what we call it. We don't focus on accuracy. So it was somewhere around 82%. And the customer asked us that how can I believe that the accuracy is going to remain same? What if over a period of time there is aging in the model and the model starts to decay? And which is a true statement. Yes, these models which are being developed, they decay over a period of time, because until and unless you infuse current and more relevant data to them, they will start to decay. So we did our research. We came up with an automated process behavior analysis chart, which is called as PBA. It's a line chart drawn over a period of time. We define the time that we will monitor the model on a daily basis, and we plotted those data points. Over a period of time, this tool, which was, I think, developed in 1944 or somewhere, process behavior analysis, helped us to identify when the model started decaying and helped us to schedule a period or maintenance period for a given model. So old trick, but was applicable in current environment also. Next, 1958, Peter Lynn came up with the business intelligence system, BI, the start of entire BI and the era of using these business intelligence systems, BI tools to track your key performance indicators, your critical performance indicators, and going forward, moving ahead your business and the competitive start of different businesses in the area of IT. 1977, exploratory data analysis. John Tukey gave the entire path to how to do your exploratory data analysis. Similarly, business intelligence, 1989, Howard Gessner. 1996, Google came and changed the world forever. 1997, Tom Mitchell wrote first paper on machine learning. And 2010, right now, they talk about the data deluge, that there's too much data, and not every data decision can be made through data. So we have been through it's a long history of data science, and it's been there for a while. Why now? Why people are talking about different things in these industries today, and which makes me question that how these things are getting so exponentially improved, developed, and implemented in this 2000 after 2000 2015 onwards. So let me give you an analogy here that a single character in computer system is 1 byte. Now, one page of around 200 is one characters around 1 kilobyte. Next, one book is around 1 megabyte. Next, you can see that one genome is around 1 gigabyte. Next, one SD camera can hold now data till 1 terabyte. We have a small terabyte chip. One entire video can be of 1 terabyte. Now, this is your Amazon forest. Your the if you convert the entire forest, cut down all the trees, which I'm not. I'm a very environment friendly person, so I don't want anyone to do that. But let's say that if anyone does it and cuts all the forest, converts that into pages and wrote all the pages, that will be around 1 petabyte. Now, uh, this is your DNA structure for a human being, and that is somewhere around 1 exabyte. So 2005, we had 130 exabytes of data. 2020, we have 1200 exabytes of data. 2015, we have 7900 exabytes of data. And 2020, this year, it was 40,900 exabytes of data. And it is, the computational capability of humans are increasing. Right now, we are in just classical systems. We have you have heard about the term GPU, graphical processing unit, and graphical processing unit enable the movement of AI because you need systems with capacity to analyze data which is in different structures, let's say text or images, and GPU has that capability, and that's where this exponential increase started. So let's talk about this chart, and this is from 2012. It's pretty old, but quite helpful to understand that the data scientists are able to capture only this around 2020, around 40,000, 5,000 data, but exabytes of data, but the machines are able to do that around 12,000. Now let's say still we have a huge scope, and this scope will be mitigated once your quantum computing comes into practice. IBM is doing research, Google is doing research, and Google recently released their quantum computer details also. IBM is having an entire cloud-based environment available for quantum computing, which is called as Qubit. And you guys can just go ahead and look into that. They have provided the entire system to even develop your own first model on your quantum computing, right? So things are happening, research avenues are being provided, and that's where we will see that another 5 years we will only talk about quantum computing, and AI will will go hand in hand, I will say, with the quantum computing. So that's all in terms of a basic understanding of this field and basic implementation of different or basic examples which are available in different areas for healthcare or other industries. But see, the core is going to remain same. You need to have data to develop a data science model. And as a statistician, as a mathematician, as a teacher, as a developer, you have to understand that you have to play around with the data. So how can you bifurcate this data into your problem statement? How can you understand your problem statement as what kind of model you have to develop, or what is your problem statement asking for, right? So for that, we go to the basic level. We take a step back and understand what kind of data I have. So the data can be two. It can be structured data and unstructured data. The structured data, which is coming out of your databases in terms of rows and columns, SQL format, and unstructured data can be your text, images, voice, your images, your videos, right? So these are your unstructured data. Now, for structured data, we have again multiple algorithms to do the classification modeling or to the regression modeling. In same case, unstructured data also, when your deep learning started picking, your neural network started picking, now we have a different high computational models which helps us to look into the data and extract features from your unstructured data as well. So let's quickly understand how these things work. Meanwhile, if you have any questions, just put it. I'll take one question and then we'll go ahead and try to understand what are the different algorithms that are available and how to understand these algorithms, how to understand our problem statement. Okay, no questions. I'm just taking 30 seconds. If there's any question, please drop a message. Okay, no questions, I believe. So let me quickly take you through understanding of these different algorithms which we talk about. Now, you might be aware of that, or let's say we just not talk that we can divide our project. Let's say we are having a data science project coming to us. They have given us the problem statement, some problem statement, and based on that problem statement, we identify that our model either can be divided into a structured data or unstructured data. So for instance, let's say they are asking us to develop a model on images for identification of pneumonia. So again, when it comes to images, we will quickly say that it is a unstructured learning. That it is unstructured data, and we need to either use best cases for images or best algorithms for images to develop the model. There can be also scenario that they are giving you, let's say, pharma data. Pharma data in the sense you can have lab-based data to identify if the person is having Parkinson's disease or not, or your diabetes or not. Okay, so that is your SQL-based data. Now, in that, the data is in form of rows and columns, and that's why I will say that it is my structured data, right? Now, first understanding is clear. Now, next understanding comes that, okay, I understood what is my data format, but what next? What I need to do? So, next level of it goes like this. A data science project can be divided into, again, two types, which is your supervised learning and unsupervised learning. Now, supervised learning, what does it mean? Whenever we develop a model or whenever we train a model, right? For training a model, it is always, we have, let's say, we should have a ground truth. Now, ground truth is, for example, I have a column x1, x2, x3, x4, and I have a column y. Now, this y is my target variable, and these are my attributes. It is called as attributes, it is called as predictors, or if you are not sure that they are attributes or not, we can call them independent variables also, right? And this is my dependent variable. My dependent variable dv is a function of these independent variables. I have to identify what is the relationship here, right? So that is part of your supervised learning. In your supervised learning, you always have a target variable or dependent variable, whatever you want to call it, available. But unsupervised learning is the case is not same. Unsupervised learning means a data set is given to you and you are unaware of what is the pattern here. You are not sure what needs to be done with the data. So that's where you will do a pattern recognition in terms of either one way that you can do is do it for rows. You want to understand that what does each row mean to you? Is there any relationship between my these rows? That is called as clustering. Okay. And second way is you do it on columns. Now for columns, it means dimension reduction, right? For example, you want to reduce, you have, let's say, 1,000 columns, and you want to understand which of my columns are similar in nature. Is there any correlation between my columns? And that's where you will do a principal component analysis called as PCA, and you will do a dimension reduction or understand that which dimensions are important, which dimensions can be merged and things like that, right? So that is part of your unsupervised learning where you are doing it. So this is for your SQL based learning where you have rows and columns. Now, when we talk about unstructured data, that is your images, your videos, your text, we are still most of the time or most of the products that you will see in current environment or whatever is available is based on your supervised learning. That means they have a ground truth available with them. A lot of research is happening in semi-supervised learning. That means half of the data we have the ground truth, but half of the data we don't have the ground truth. Okay, so training is happening on this data, and then they are developing the ground truth for another set of data. So that is kind of your semi-supervised learning. Now, similarly, unsupervised learning, there are certain algorithms, but a lot of research is happening in terms of which cases are available where we can do a end-to-end unsupervised learning to identify the patterns and things like that, right? So that is again work in progress sort of. But a lot of research you will see which is available, a lot of papers are available on your supervised learning for different industries, different areas in your unstructured data part. So that is the core understanding behind choosing your algorithm. Now based on that, now we can identify which algorithm to use. So again, I'll pause for 30 seconds, and if there are any questions, I'll take questions. Let me quickly see. Okay, no questions, I believe. Deepa, I'm audible, right?
Yes, sir.
Yeah.
Participants, if you have any questions, feel free to post it in the chat box so that sir will reply whenever possible. So maybe towards the end they might ask. Yes,
Sure.
there's one example question, sir.
Can you share an example of dimension reduction? Okay, dimension reduction. See, I did one of the projects for e-commerce industry. Now, e-commerce industry, what we did is we developed a survey, and that survey was to identify customer behavior in terms of being loyal to any one platform of e-commerce industry. So I cannot take the name of company, but yes. Now, in that, what we did is we developed a sort of survey. Now, the survey was to identify critical parameters influencing the loyalty of a customer. And what we did is we took around 110 survey questions. Now, all survey questions were based on Likert scale. So Likert scale is nothing but your, anything between, let's say I'm using a 5-point Likert scale, so that will be 1 to 5, 1 being, let's say, worst, and 5 being best, right? Now, based on these 110 questions, we were able to, and we took around, the sample size was 1000. So we took survey from around 1000 respondents, and based on that, based on this data, we did a principal component analysis to reduce the dimension. Now, when I talk about reduce the dimension, what I mean is I need to merge out of these 110 survey pointers, which is, let's say, parameter x1, parameter x2, parameter x3. Every question is one parameter until parameter x110, right? I wanted to merge or identify if there is any correlation between, let's say, x1, x2, x3 are of similar pattern, and they can be merged together as xa. Similarly, xb can be a component of x5, x7, and x10, like that, right? So this helped me, the dimension reduction here helped me to identify what are the critical parameters and how are those critical parameters dependent on other parameters. So let's say customer loyalty is dependent on, the output was the customer loyalty is dependent on technical use, that is how the end user, how the product is developed. For instance, how the GUI, graphical user interface of the system or of the e-commerce portal is. And next was usage. How many useful products are available on the tool? And the third was freebies, or not freebies but discounts. Let's say how much discount is being offered. So these three plus another, I think there are 5 or 7 different parameters which we were able to identify out of these 110 different questions. So that is one example of dimension reduction, which which I worked on in past. And based on this, so it didn't only stay till here. Based on this, we developed a final algorithm that anytime the similar survey is rolled out, we will figure out that the customer will be loyal to the e-commerce portal or not. And if the customer is not going to be loyal to the e-commerce portal, then which area is he rating less? Now, based on that, we developed a response model. A response model, if let's say person is not happy with the products which are available in the portal, then what we will do? There was a task team designed, and the task team went ahead, discussed that which products we want. So that way, the entire model helps in running the business in terms of getting the feedback from the customer, and based on that, keeping the product, keep developing the lines, doing innovations in terms of your graphical interface, uh, producing very smart interface in terms of what customer wants. Sometimes even the customer, for example, Amazon, you can see that the interface is developed for each person. The interface differs. So based on your historic search, it updates that what you could like, what you couldn't like. And this project was done in 2014, and after that, the recommendation engine came, and the recommendation engine part became the part of this e-commerce portal. So with the help of PCA, we were able to do the task of entire developing a recommendation system for us. So quickly moving to the segment where I'm talking about different algorithms. Now we understood that yes, we have something called as supervised learning. We have something called as unsupervised learning. Let's talk about supervised learning and how algorithms differ in this area. I'm taking an example of SQL based. We will take an example of unstructured based in the later half. Now let's say when we are doing this, we can do two types of things. Either we can do a regression or we can do a classification. Now, in case of classification, what does differ here? You will ask me, Swapnil, what is the difference between a regression problem and a classification problem? Now, we are 100% sure that there is a ground truth available to train the model, right? That means whatever is output generated, that generated output can be referred to the ground truth. And when we are training the model, your y is a function of different x's, right? So we can train the model. A mathematical equation, in short, can be developed between these two. It differs that whatever algorithm I'm going to use, the mathematical function will change. Here it can be a linear regression or logistic regression or let's say naive bias or something like that. But one thing is pretty certain that I have a ground truth and I have different attributes. Now, when we are doing this for a regression problem, the output is always continuous variable. When I say continuous, that means it is number, right? It can be, let's say, it can be 0.5, 0.7, 100, 0.7, 1000, 0.7, something like that. But it is in numerical form. When we are talking about classification, it directly says that it is a class. That means either it can be a binary, the output is either yes or no, successful, not successful, the person is having the cancer or no cancer, right? Or it can be multinomial. So here it can be, for example, the person is having acute cancer, or it can be minor, average, or major, right? So that means more than two variables are available in your target variable. Now let us understand this in this example. Well, let's say you have to identify diabetes. Now you have different rows. In this, you have different x's, x1, x2, x3. Now a simple problem which says that your y is let's say yes, no, yes. And here the entry is for each person. So first person code is 1, second person, third person. Now what does this mean? That it's a binary problem, binary classification problem, which says that the person, you have to identify or you have to develop a model which gets trained in terms of identification that based on these three parameters, x1, x2, x3, my patient is going to be a or is a diabetic patient or not, right? Similarly, let's say they have levels, different levels of diabetes. There are, let's say, L1, L2, L3, and L4. Now, similar data set, you have attribute 1, you have attribute 2, you have attribute 3, and in that one, you are being marked as for first person it is or fourth one can be no, right? So first one it is no, that means that person doesn't suffer from diabetes. The second person it is given as L1, third person L1, fourth person L2, and L3. So here what it becomes, and there is one more person which is with, let's say, L4. So different levels of what you want to predict, or what is your problem statement here, that first of all identify that the person is having diabetes or not, right? And second thing, it will also help you to identify what is the level of diabetes. It is L1, L2, or L3. Now, based on this data with the attributes, you can train a model to do this job, right? So that is your classification. And similarly, regression, again, let's say a sales problem where you want to predict the revenue or let's say profit of different years or different teams. So profit is going to be a numerical number, and in that case it becomes a regression problem. So that is the core difference between when you are selecting what kind of project it is. So you have to do a deeper understanding to understand what is your target variable, and when you understand your target variable, it makes it clear that what is your problem statement in terms of what you are going to develop, which model you are going to develop. Either you are going to use a regression based algorithm, or you are going to use a classification based algorithm. Now, to clarify these things in further, which algorithm to use, I always take example of SAS sheet for machine learning. So this, even you can Google which machine learning algorithm should I use. Now they have given pictorial way of, a very good pictorial way in terms of identification of which algorithm you should use. Let me quickly check if it is available here. Hmm. Okay. No, it is not here. Yes, this one. Now, as you see, we are talking about here, this one, supervised classification, supervised regression, right? Now, let's say you started, okay, you start from here, you understand what is your problem statement. So my problem statement, first one, example case, you have to identify critical parameters which are influencing, let's say, a patient's health. And you have, let's say, 1,000 columns. And from that 1,000 columns, you have to identify which are my problematic, or which are different, let's say, different dimensions on which my health of a patient is dependent. Then you will do a dimension reduction. And here you can understand what is the different models. If you are doing a topic modeling, that means every x, x1, x2, x3, x4, every column becomes a topic for you. Then you are going to do a principal component analysis. If you are going for a much deeper probabilistic way, then you can do a latent decade, or you can do a singular value decomposition. But most of the times we use topic modeling and principal component analysis to do this job, right? Now let's say next one, you have responses or not. So this is a flow chart. If you don't have responses, then what you are going to do, you are going to do a clustering. I don't have responses. I want to understand my data better. I have to identify what is the pattern of my data. And in that, you have multiple algorithms. For example, the best one that is being used is K-mean right now. We also use hierarchical clustering, but most of the times we use K-mean. Okay, so that is your clustering. Now let's moving to you want to predict something in future. So based on the model you have trained, you want to predict that how your model is, in future you have the similar data set and you want to pass it on to your model and identify what is the predicted. So are you predicting number or are you predicting class? If you're predicting number, then you go for a regression problem. Now in that you can use random forest, you can use neural networks, you can use gradient boost, you can use decision trees, linear regression. You can also use neural networks. It is not the case that you cannot use neural networks here. I have developed certain models which where I have used neural networks for predicting the cycle time of analyzing the entire or cycle time that it will take for a machine to complete the task, and there neural networks gave me the best accuracy rather than support vector machine or your let's say linear regression. Next one, if you're not predicting a number, if you're predicting a class, then in that case, you have again multiple algorithms, support vector machine, random forest, neural networks, gradient boosting, decision trees, your logistic regression, your naive Bayes. So based on this structure, you can select your model. Now, it is not like you choose a selector different algorithm and based on that algorithm only you develop a model. No, that is not the scenario. Whenever you develop a model, you do on multiple algorithms. For example, you might use random forest, you might use neural network, and you might use gradient boosting, and you can use logistic regression. I'm just taking an example. Now, based on these algorithms, you will see which algorithm is giving me the best result. So it can be a scenario that you are selecting it from ensemble techniques, random forest is giving you the best example. Now, in that, you can go ahead and identify, you can do, it is not only about selecting the best algorithm, but it is about that how you are tweaking its parameters. So every algorithm, again, it's a mathematical function, and mathematical functions comes with their own assumptions, right? So you can tweak the assumption, and we call it hyperparameter tuning, right? So you can do a hyperparameter tuning on those algorithms so that they give better accuracy. You in production, for example, if we are talking about corporate environment where these softwares are being developed, the products are being developed, we are not relied on one single algorithm. Rather than that, we club outputs of different algorithm and develop a sort of package which is used in production to give the output, right? So this link, you can just Google it to understand different algorithms and how you can bifurcate a project into different algorithms. I think over the sessions you will be going through these algorithms in detail, but yes, that helps me to identify what is my problem statement, and based on the problem statement, I go ahead and select the different algorithms on my data that is given to me, right? Now, similarly, there is uh, one certain scenario when right now we were talking about, structured uh, data with, you know, it is having a function of y is equal to fx. What changes in your images? What changes in case of your, let's say, text, right? So the these algorithms, when we talk about, let's say I'm taking an image. Now in image, each point is a pixel. I play around these pixels. I convert this image into an array, right? And use this pixel. For example, I'm just taking 0, 1, 1, 0. This is a small image that I have. I have converted into pixels, and then I use this array as my input variable. Again, it goes to the input variable, my model takes it, it goes to my target variable, checks if the output is correct or not, or it backpropagates. Okay, so that is something which is happening with the images. Now neural networks do it in a very better way. For images, the algorithms we use are called as convolutional CNN, convolutional neural networks. And in convolutional neural networks, again, we have different type of convolutional networks. One is for classification. So that means you have to just classify that it is a, let's say I'm taking an example of it's a dog or a cat in an image, right? There's another set of algorithms which is for object detection. So for instance, in this given image, a cat is sitting here. You just don't want to know where is the what is this image about, but you want to create a box around the cat. So that is your object detection. Then there is something called as segmentation. Now, let's say this is an image, and here you want to identify, you want to just segment that there is a cloth, there is a person wearing the clothes, but where is the what is the cloth, or where is the cloth in that, right? So let's say that segmentation that is done through segmentation algorithms. So different, again, in CNN we have again different hierarchy and different set of algorithms to do these jobs. Similarly for text, the prominent examples of classification is sentiment analysis. So let's say I was recently doing one of the projects for one of the clients where they gave us their NPS data. I'm not sure if you are aware of NPS, but it is called as Net Promoter Score. And this case study is prominent in healthcare also, because they get their net promoter score, they get the feedback from the client, right? So this is nothing but your feedback from the client. Now, once you get the feedback from the client, it can be in terms of pointers. Let's say the same case, Likert scale, and they've given 1, 2, 3, something like that. Now, based on that, we also give them option to comment, right? So they give full text here. Now, sentiment analysis is nothing but using this text to understand what is the sentiment. The user tone is angry or sad or happy, things like that. A similar way, another model in text can be created, which is called as topic model. Again, a very good example. Now, topic modeling is not your structured learning. No, it is unstructured learning where you have lines of text here. In sentiment analysis, it is tagged to some kind of learning, right? So, for example, there will be labels created in terms of happy, sad, things like that. So, you have a supervised learning. But topic modeling in text is not an example of supervised learning, but it is an example of unsupervised learning where through the text, let's say prescription is given, and out of that prescription, or summary is given. Then out of that summary, you want to identify what are the core problems that happened for last 100 patients, right? So similar model can be developed for using topic modeling, and it will give you output in terms of keywords that are repetitive in nature or things like that. That the model found that there is some kind of pattern there, and with the help of keywords, you will be able to identify or structure or give category to those summary or to those prescriptions. So in text, a lot of things happening in both in your supervised learning area and unsupervised learning area. So these are the different data science areas or different data science algorithms and their usage in various industries. So same use case can be used in banking, same use case can be used in uh, uh, your manufacturing. But the only thing is, or e-commerce, the only thing is that the modeling, the data science team, how do you gather the data, which algorithm you are going to use. There are multiple algorithms that are available. The core understanding lies on how to do your project, how to identify your project, and how to structure your project. Now, to structure your project, you can always go through, there's something called as CRISP DM methodology. This helps. This is quite being used a lot in the industry. It is called as cross-industry process for data mining. Now, this helps us in identification of the project. Let's say I'm starting. I've covered the business understanding and data understanding, right? This goes hand in hand. So, business understanding, what is the business goal? What is your project plan? To data understanding, that how you will collect the data, how you will verify the quality of the data, and how you are going to exploit the data. The next segment is your data preparation in terms of how you are going to prepare your data, any kind of structured or unstructured, how you are going to put into your model. That is, what are the pre-processes that you will do on data to make sure that the data is processed well by the model. So that is something that you have to do, which we will quickly see in the example as well. I have done these steps in the Parkinson's case study. And next part is evaluation. You should have evaluation parameters. So there are multiple evaluation parameters. For instance, if you say a regression model, there can be R squared value. If you say a model evaluation for classification model, and this remains same across your industries. If it is a structured problem, if it is a supervised learning problem, then you will develop a confusion metric. You will calculate your accuracy. You will calculate your recall, specificity. You will calculate your reference score, things like that. Right? So you will do your modeling. You will do your evaluation, and then after that, you will go ahead and deploy your model using again your data engineering team. Right. So this is the CRISP DM methodology in brief. We were talking mostly about this area because 70% of the time in any given project, 70 to 80% of the time, it takes in understanding the first, the second, and the third, which is your business understanding, data understanding, and data preparation. These take the most of the time of a data scientist or a data engineering team to work in parallel so that they have a proper data prepared for modeling. From modeling to evaluation takes another 20%. And then comes the hardest challenge of deploying because they have to create a pipeline to make sure that the deployment works properly. So another 10% goes in that, right? So that's how your any data science project time consumption, it will look like this. Quickly, now I'm moving to the case study. I'll pause for 30 seconds and wait if there's any question. Any questions, guys? So next 15 to 20 minutes, we will spend on a case study. Now, as I have mentioned that this case study is coming from healthcare background, and where this is an open data source, and even you guys, you people can go ahead and just Google Parkinson's data set for.
So, do you need a break, sir? Or are you comfortable to continue?
I'm comfortable to continue.
Okay, sir. I think one question is also posted.
Yes, I'll just go through it.
Yes, sir. Yes, sir.
So Ravi is asking that how transfer learning can be done from, let us say, healthcare to telecom. See, transfer learning cannot be done in this case. I'll say industry-wide. For instance, let's say you are developing a model. What does a model save? When we talk about transfer learning, we have to understand that what is that which a model saves. Any model, let's say. So any model, whenever we develop a model, any prediction or any classification or any clustering or regression model, the code structure is y your target variable is equal to, let's say, weight 1 x1, weight 2 x2, and let's say there are 13 parameters similar to this. So weight 3 x, or sorry, what 13 x13, and plus your y. Now, whenever you develop a model, the model saves the values of this w, 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 and your e. So what does it save? It saves w1 to w1, w2, weight 1, weight 2, weight 3, weight 4 till weight 13 plus your bias value, right? Now, that is the equation parameters that it fulfills and it saves. Now, when we talk about transfer learning, in transfer learning, what is happening? That you use these weights in different, let's say, different area. So the same algorithm, that means same that you have saved y, and I'm naming it as y of industry healthcare. Can it be used on y of industry of telecom? No, that is highly not possible. But there is something called as transferring the use case. So it is not part of transfer learning, but transferring the use case. Right? For example, in healthcare, you are developing a model for detection of diabetes. Right? Now the same process can be used in telecom to develop a model for detection of defect Now, telecom, we talk about network routers, switches, servers, etc. So, detection of defect from, let's say, network devices, right? So, same way, for example, if you are doing developing a healthcare project for this, it is similar to your case study of telecom, and vice versa, you can do the same learning here. The weights and bias will not be transferred in this case, but in this case, mostly your process can be transferred. The same process that you have done in diabetes, identification of diabetes, you can do a similar kind of process in, but your data set will entirely change. Now, if this is just in the case of SQL data, right? What if you talk to me about, let's say, sentiment analysis using for text analytics? For your using your let's say BERT model. I have done this job. This transfer learning on text to text is very easy. So here also in healthcare also you will have data for your comments will be on your feedback, right? So the data here is feedback. Similarly for telecom, the comments will be your feedback. So here in this given scenario, your transfer learning is quite useful. I have just used a BERT trained model on a different industry data and identified what is my sentiment. Similarly, topic modeling. Now, topic modeling, here the topic will change. Healthcare, the topic will change. Telecom, the topic will change. But the model that you have prepared can be used. So here you can do a transfer learning. Now, if you talk about, let's say, images, right? So images, there are a lot of, you can use the transfer models because when you develop a image-based model, you either freeze your training layers. In images, when you go in deep on convolutional neural networks, there are different layers. So you can either 100% make sure that your all layers are freeze. That means you will use the existing weights and bias in your data set to do the prediction, or you can partially open and close 40%, 30% of your layers you can freeze and keep the 60% for your training and things like that. So that transfer learning is possible. So again, we have to think from a project perspective or from a project statement perspective that what you are trying to do, and in that case, if it is applicable or not. So there are areas where it is applicable, there are areas where it is not applicable. I hope that makes sense. Okay, so Praveen has asked, sir, what about data pre-processing? I'm taking you through a data pre-processing entire project. So let me go to my Jupyter notebook. Again, who are aware or not aware of Jupyter notebook? So Jupyter notebook is just give me a second. Yeah. So this is an environment which helps me do a Python, develop a Python code. There are multiple environments available, IDEs available for Python. Here I am using a Python 3x version, 3.x. I think the latest version, which is 3.7 point something. And I am developing my code on a Jupyter notebook because it makes very easy to understand. Now the case study that I'm going to take you through is a Parkinson's disease. I'm not. Most of the people will be aware of this disease, that this is a degenerative neurological disorder which decreases your dopamine level, and dopamine is nothing but it is let's say it is a neurotransmitted hormone that plays very important role in controlling your body movement. Okay, so what happens that uh, this disease manifests through deteriorating the movement, including your body. You will A person who is suffering from Parkinson's disease will face tremors, stiffness in the body. They will not be able to speak properly. They will have sort of like difficulty in articulating the sound, difficulty in speaking. Their voice will become very lowered. It will be not monotonous for other person to hear. That means they will not be able to module their voice from one pitch to another pitch. So these are multiple cognitive impairments and challenges with a person who is suffering from Parkinson's disease. There is no 100% cure in case of Parkinson's disease, and uh, it takes a lot of time to clinically identify if a person is suffering from Parkinson's. Until the time it gets diagnosed, the symptoms becomes very severe. So, to make sure that a person gets identified in an initial stage only of Parkinson's disease, there was a team who did research, who developed the data set and then made sure that the data set is, open source. So again, the data was taken from 31 people on different biomedical voice measures, because what people found that when a person is speaking, it will be very easy, or it becomes easier to identify if a model is trained on the voice parameters or attributes that to identify if a person will suffer or is suffering or is an initial stage of Parkinson's or not. Okay, there are different attributes. Out of these 31 people, 23 people were suffering from Parkinson's. The rest 9 or 8 were not suffering. Now, the data set which we have, each row corresponds, or each row is a particular voice measure, and around 195 voice recordings were made on these 31 people, so that they have different samples. So entire data was created from scratch, and sample size of 195 data points is given to us. See, what are the different attributes available in this data set? So we have name of the person. Now this is an ASCII subject name and recording number. Then we have different parameters as I'm talking. We have something called as average vocal fundamental frequency. We have maximum vocal fundamental frequency. So these are attributes in your voice when you are talking. Minimum vocal fundamental frequency. They all are marked as MDVP, F0 for fundamental frequency, FHI for high, FLO for low. Now, similarly, they have different jitter levels available. So, jitter percentage, that how much the person is jittering. Several measures on variation of fundamental frequencies. When you speak, there are different modulations that happens in your voice. So that is your jitter, right? Then you have several measures on variation of amplitude. How much is the amplitude in the voice, or when you're talking, what is the amplitude in your voice? That is called as shimmer. Now, after that, you have ratio of noise and tonal component in voice. What is the ratio? That could be because of the background noise or some kind of you might have a sore throat. You have been speaking for so long, so that could be a noise in the ratio of noise and tonal components in your voice. Similarly, health status of the subject. That means one, it is Parkinson's. The person is subjected to Parkinson's, and 0, that means the person is healthy. So now let us understand. We have different X's available. We have output. This is a clear-cut problem of supervised learning. Now, in supervised learning, is it regression or classification? If you can comment in the chat section. My question is, if it is a classification problem or a regression problem, and if it is a classification problem, what is the classification level here? Any suggestions, any queries, or if you're able to understand what is the problem statement here? Okay, I got reply from, yeah, good. Yes, Ravi. Yes, Swapna. So this is a classification problem. It's a binary classification problem that is suffering from Parkinson's or not. Exactly. Then we have two linear dynamically complex measures, significant signal fractal scaling component, and there is three non-linear measures. Again, everything is related to your voice levels, your modulations in your voice, your frequency of how your voice is speaking, what is your amplitude, what is your frequency variation, and things like that. Just imagine how many people would have been involved in this project. When I need a person who is understanding vocal sciences. Just imagine the person who understands voice and who has done research on resonance, frequency, a person who is coming from core physics background, a mathematician required to create a model, a coder who can develop the machine learning model, right? So different people coming together to complete on one to work on one single given problem. Plus doctors, physicists, your lab technicians, or the people who work on labs who used to identify if a person is Parkinson's or not. So multiple domain experts coming together to work on one problem. Now, I will not go into the coding part, but I want to show you the part or in terms of how data scientist works on a given problem. So we download multiple modules for visualization. For instance, basic libraries, you can see NumPy and Pandas, data visualization libraries, Seaborn and Matplotlib. Then after that, I'm downloading. I have built this model in using Ansible technique, but you can use anything. Ansible techniques are your decision tree and different modules of decision tree or different variations of decision trees. So here we have decision tree classifier, backing classifier, data boost, gradient forest, and gradient boosting and random forest. I'm downloading packages to develop to split my data into training and testing since I don't have liberty to procure more data. The 195 data points is only available to me, and that's why I have to make sure that when I'm doing my proof of concept, I should develop my analogies in the existing data that is available, and that's why I have a train test module to take my training data, let's say 80%, and testing model 20%, develop my model using the testing data, and test it on my testing data. So I will split the data into two formats. Then there are certain columns which we are using for data skill and pre-processing and metrics to evaluate the model. And then hyperparameter tuning is done with the help of grid search CV. So these are different packages which are available in Python to help you perform a data science project. And if anyone interested to learn more in detail about them, uh, by beginners, you can start from a Udemy courses, machine learning for data science is the course name by Kirill. So you can go through that course and that will help you to understand this entire coding part from Python. Okay, so then I am downloading my data. This is the archive which is available, and it is from UC Berkeley College, and the data is available. So I'm just extracting the data from the given URL. Then after that, we see the data set top 5 units. I'm seeing that I have all the columns that we have discussed available here. Majority of those columns are available. I'm doing a sort of data pre-processing. So first of all, things that I do is clean the data. Any, sometimes what happens that before the data or after data, when you're downloading it, there could be a space. So that becomes challenging when we are formatting or when we are writing the code. So that's why I'm stripping the data white spaces in the column header by data visualization to see if there are any white spaces or any uh, uh, data points which are not available, missing values available in the data. So that's why I'm just plotting a chart for it. And this chart shows if there would have been any missing values, it would have come as a yellow point. But right now, my entire structure is purple in color, and that's why I can say that there is no missing data point. Then, I always, if it is a smaller data set, if it is not a big data, I always follow that the data should have, I'll go through it in Excel sheet. That's my one best practice that for a smaller data set I follow, that I go through each of the columns and just check out if there's not any anomalous behavior which is there. We can also see the blank values through through just running the data frame and see that there are 195 data points available for each and every attribute, right? So then I'm starting with in the data pre-processing itself, I'm doing a univariate analysis to understand what is the different parameters on different parameters how the data stands. For example, uh, what is the mean, standard deviation, min, 25%, that is your quartile 1, quartile 2, quartile 3, and maximum, right? So what are the different values? This helps me understanding if there is any anomalous behavior, if there is any sort of your, let's say, for instance, just give an example that your shimmer value will always be positive. Now, let's say if it is negative, that means that there is challenge or there is anomaly in recording the data, and that's why I'll go back to the data or to go back to the data owner and see that if that makes sense. I will go to the domain expert and ask them that if that makes sense or not. And if they say that yes, that makes sense, I'll go ahead with the data. Else, I will do manipulations with the data to make sure that that anomaly is removed. So quickly, doing the bivariate analysis to understand what is the relationship between different status and how the counts are happening, how their mean are going through, for which, for instance, if you see the mean, standard deviation, and median of attributes related to vocal fundamental frequency, that is your MVDP, MVDP high, MVDP low, patient, it is greater than healthy person. Let's see how did we come to that analogy. So you see here, 0 is your patient, 1 is your the person who is not suffering from Parkinson. Now, if you see here, for patient, it is these three parameters: MVDP, FO, high and low, are greater than the people who are not patients. That means this parameter increases when a patient is suffering from Parkinson, right? Similarly, we will check out the standard deviation also. So standard deviation also increases and your median is also high, right? So that helps me understanding that this becomes a critical parameter for me and when I'm developing the model. Similarly, you can check out for others as well. So that is something that Python helps me to understand quickly when I do this kind of analysis. Now moving to pair plot analysis. Pair plot analysis helps me to understand the trend between different attributes and how they are moving ahead. So quickly moving to the correlation. Your correlation plot helps you to understand what is the relationship between all these variables. You can see that there is a high correlation between, first of all, we check out with the existing your dependent variable. So your dependent variable is, just give me a second, it's a huge file. Let me see if I can open the tab. Yeah, I can. So only this thing will open, so it is often used. So status. Now status is your how different parameters are affecting the status. So the how I will read it, status, it is negatively impacted by your MDVP. It is positively affected by rest of the things, and no very higher correlation, but no very low correlation also. So your range is between 0 to 1 and -1 to 1. -1 is negative, 0 to -1 is negative correlation, and 0 to 1 is positive correlation. Now, in that, these are not very strong, but average correlations is what I can say, right? But there is a higher correlation between shimmer all the parameters of shimmer, which is bound to be, because these are all parameters related to one single entity, which is your shimmer. And similarly, for jitter also, there is a high correlation between the data points, right? So in correlation analysis, this helps me develop analogies in terms of which attribute to use, which attribute not to use. Is there any attribute which is showing very less correlation and things like that. Then for identification of outliers, we do a box plot analysis. So you can see here that MVDP, we have huge number of box outliers here. So we do something called as outlier treatment to develop to remove the outliers from the model, right? So now I'm dividing my data into training and testing set. So I have divided my data into, first of all, dependent variable, which is my status, and all other rest goes into my independent variable. I divide my data set into train and test. I'm using a 70-30. So that's why you can see the test size I have given it as 0.3. So that is the next step, to divide your data set into training and testing. Then after that, I'm developing my first model using decision tree classifier, right? So, you might be thinking that it's a big step to develop a model, but these 3 lines: take the classifier, fit the classifier, and predict. These 3 steps only used to develop any prediction model, right? After that, everything before that is everything data pre-processing, and after that, everything is your model evaluation and hyperparameter tuning. So the first model that I have developed, it gave me a prediction rate, or it gave me a accuracy of 0.74. That is 74% accurate, right? Similarly, as I have mentioned, that there are multiple parameters or hyperparameters involved in any of these models. So the 2 parameters which are involved in decision tree is your maximum depth, that is the depth at which you want, what is it is always a hierarchical structure, right, in decision tree. So let me quickly show one second. It is always like one, and after that next layer, then after that this will split into next layer, and this will split into next layer. So things like that. So decision tree, this we can control it. We can control that till what level your model should be developed. Then how many sample leaves you should have. That is another parameter that you can use. So I am taking these parameters, I'm giving it some values based on my understanding of the model, and then it gives me that what will be my best parameter. So my best parameter is going to be max depth of 5, and my accuracy will increase up to 81%. So from 74% for a basic model, I have reached 81% for a using the hyper parameters, right? Similarly, one more example that I want to showcase here is why we do multiple times. We develop models on different, let's say, random forest, or why we use different algorithms, right? Now, if you remember, the basic decision tree was giving me a 74% accuracy, whereas my random forest, now this algorithm is developed in such a way, the background mathematics is developed in such a way that on the same data set, it is giving me 86% accuracy without hyperparameter tuning. Now, let's see if I do a hyperparameter tuning on different pointers which are available, what is the accuracy that it gives me? So let's see, it gives me 85. Yeah, it is almost same. 86.15 is max I could reach on this algorithm. Another algorithm I have done through bagging boosting. So bagging is giving me 84%, ADA boost is giving me 86%, and your gradient boost is giving me 88%. And in medical data set, 0.1 or 0.01 is also, it impacts, because that should reduce my false positives, which is your which is false negatives, which is critical. It should not give me multiple false negatives. And for example, if a patient is not suffering from diabetes or not suffering from Parkinson's disease, and I started his treatment based on this model, that is not good, right? So that is the case study that I wanted to showcase you in terms of, we can develop the model. It's pretty easy now. I will save this model. Let's say GBCL predict is my final model. I will save it. Then I will create a similar pipeline for another future data that comes in and pass it through the pipeline, and that becomes my product. And I will I will ask a user interface developer to develop a user interface for me, so any doctor can pull the data, or fill the data into Excel sheet and then pass it on to the model, and the model will give that the person is going to be a or is a Parkinson's patient, or what level of Parkinson's patient. If I have the levels also, it can help me in identification of a patient who is uh, going to be a Parkinson's patient, right? So yep, I think yeah. So that's all from my side. I am open for questions. So let me know in case of any questions. So Deepa, that's what the content that I wanted to share with all the teams. So
Yes, yes.
key takeaways. There are different models available. There are different open data sources available where you can play around with the healthcare data. Go to Kaggle and look for healthcare-based Kaggle competitions in past. From eye retina to your lungs, to identification of your cancer in lungs, to identification of uh, your pneumonia, acute pneumonia or chronic pneumonia in lungs. All these data sets are open source. So any practitioner, any researcher, any academician can go ahead and develop their own models, learn the skill. Second thing is SQL-based data set related to diabetes, related to Parkinson's, and related to other disease, for even cancer identification also is also open source. So those data sets can also be found on UC Berkeley website, or there are different colleges website, and you can go ahead and learn the skill of developing uh, predictive models, machine learning based models for healthcare. The approach for across the industries remains same, only with tweaking on the best practices. And the base is that you will pull the data, you will do exploratory data analysis, you will do a data pre-processing, you will perform feature engineering in terms of extraction of features from the given data, and then you will pass it on to your model, and your model, with the understanding that it is a supervised learning model or an unsupervised learning model, and the model will give you the output, and you have to evaluate the output, that how your model is performing, and then you do a hyperparameter tuning to make sure that your model performs well, and then you take it to the production, and then your post production things start. So that is across in my career, I have seen that had been the process anywhere, anytime you take up any initiative or any project related to data science. Yep. So that's all from me. I'm open for questions.
So there's one question I think one participant has posted. Is that can you see,
So
sir?
yes, I can. So Soumya has asked that in the same way, can we find for dementia whether the data will be similar for it, or it will vary in any parameters? Sorry, Soumya, since I am not the domain expert in terms of these diseases, so only a practitioner, a doctor, can help us. So for Parkinson's disease, as I mentioned, that a lot of domain experts came in together and worked on one single problem. Uh, so I will not be the right person to take a call that for dementia the parameters are going to remain same or not. Could be, could not be. So that's why only a practitioner can guide us for diseases. K. Dr. K is asking, is the data set image or data tuple? So for the Parkinson's disease, the data set is a SQL based data set. other data sets that I'm talking about, for instance, starting with your chest-based, X-ray based, or MRI based, those are all images scans, eye retina scans, and they are images. So they come in an image format. Yeah. So you have to build your models based with the help of convolutional neural network.
So thank you so much, sir, for devoting your time and so much of effort you have put in for explaining whatever you have gained through your rich experience. So there were a lot of takeaways that the participants have got from your session. And in fact, the last project, the Parkinson's project, was really awesome. And I feel like the participants is the first day, and the participants are really lucky to have an eye-opening session that you have given to them, sir. From our management, the management of KCG College of Technology, and from the entire event coordinators team, I would like to express the heartfelt gratitude to you, sir, for accepting the invite. Even in spite of the fact that you were busy in your work, and every time I used to call you, get the thing, you were telling that you are busy in your meetings, but you found time for us, and you have shared so much of information. Once again, thank you so much, sir. And
Thank you so much. Thank you so much, Deepa. And
yes,
so, uh, academics is one part that I always like to deliver content. Uh, any questions for anyone if they want to connect me offline? Whenever I get time, I do get in touch with the LinkedIn profile. So I'll be sharing this presentation with you. You can share it across across this forum. And if they
sure,
want
sir.
to ever get in touch with me, they can drop a note me on LinkedIn.
Thank you so much, sir.
Thank you so much.